Hi, my name is Chen again. I will demonstrate my assignment 1, part 2, CAD2 for the CAD cam. Firstly, as usual, we choose the machine as the June Milling _3S1. Then we choose our store from the click the top surface of here. Then it automatically create a box for me. And I also choose to expand the box on both XYZ direction in 2 mm for the clean procedure and for the later cutting shape. Then the coordinate system, we also choose the bottom left corner as the data point lying here. Then, as the last CAD model show, because this one is the rectangular block, we need to choose two small rectangular balls on both sides to hold and lock this one lock stably. Then we will proceed the next step. Yes, first one we will do the clean procedure like before we do. We will use the 3D. We will use the face milling procedure, and we will use the tool. We will tool fluid HSS M mill, and for the diameter will be 25 mm, which could be chosen largely on the face milling, which could improve the speed of the manufacturing. Then the step will be 2 mm for the depth. Technology will be counter, the most better way for the finish. Then we go back, we finish the first procedure. And I forgot to mention on the first video as well. After every step of manufacturing process, we need to take the part, the stop out to observe the feature and the cutting is okay or no. If the procedure is okay, we do for the next procedure. If the observation with a set is not okay, we will stop this manufacturing and we start again. And we double check which part will be going wrong, we fix them, and then we go next step. And yes, this is a repeat procedure I will do for the next or the manufacturing process. But I just mentioned here, but I will not repeat in every step. I just mentioned in my video, not me, but in the actual real world, we need to do it in every step. All right, and then we flip opposite for the store object. In here, we do another face milling. Still the same tool fluid, HSS, M mill, 25 diameter, 2 mm for the depth, counter technology. All right, then after we clean the both top and the bottom surface, we will do the 3D milling. For this 3D milling, we aim to cut the depth, the feature until like this outside, this circular. We will cut this one up to this step, and also for the inside, we will cut up to this, to the circle top, the top of this circle. And luckily, very luckily, the bolt depth from here and from here will be the same. Therefore, we can conduct this operation together. And in here, we choose the tool will be M mill, tool fluid, HSS, and will be the diameter only 11 mm because we need to cut the detail for the circle and the outside stuff. And yeah, we need to make sure the cutting length is long enough, 8 mm, outside hold the 50 mm. And the level we cut will be 8 mm for the depth. Therefore, we can separate in 4 steps, and each step will be go deeper 2 mm. Technology will be counted, and we we choose to use the semi-finish circular technology pocket, 1 millimeter wall offset, and the finish will be used the circular pocket finish. Cause what we are cutting the shape is almost in the circular shape. Therefore, contour will be the best, and the circular pocket will be the best as well. All right, then after we have this shape of this circular, we start cutting the inside characteristic for this one inside. We will choose again 3D milling will be the one of the powerful technique. For the tool, we choose M-mill 2 flue HSS diameter 11 millimeter, and the cutting depth still 8 millimeter enough. Outside holder 50 millimeter. And for the level, we need to cut from all this one you see 1, 2, 3, 4. This 4 feature, and this central circular hole to the bottom like this up to here. Therefore, the depth will be from -2 to -14. Then we will have all these 1, 2, 3, 4, 5 features for the cutting inside the circular path. And in here, as what we say at the beginning, will be counter, semi-finish, circular pocket, 1 millimeter for the off-wall offset. Finish will be the circular pocket. Then it done the inside features of this circular path. Finally, we're not done yet because we still have this. You can see the rectangular empty space in here. We didn't cut this feature just now. Therefore, we will choose the tool M-mill 2 flue HSS. Diameter will be 8 millimeter because we can cut this one fit very fitly for this empty space. Cutting depth will be increased 24 millimeter. Outside holder will be still 50 millimeter. And the cutting depth will be 0 to 10. So from this top to here, around 8, but we cut the both top and the bottom surface for 2 millimeter just now. So here will be 6 or 8 around here for this cutting space depth. And we will divide this one into 5 steps. Each step will be 2 millimeter for the cutting depth. And for this technology, because it's not circular, it's better to use hatch. For this hatch, it's better to cut the rectangular shape. But we still can't apply the semi-finish linear. 1 millimeter for the wall offset. And the finish, we choose linear for the rectangular shape. All right, and finally, we could done all this. Remember, we need to observe each step. And I will calculate the whole process to show I do the correct step. Just like the first CAD model I made. And I will simulate to show the correct pathway. VD. Step by step, but I believe this one will be quicker than just now another one. So we probably wait for this one to finish. All right, still takes time. Yeah, up to here. We almost watched the whole procedure. Stop. Finish. And on the last CAD video, I want to show you I'm qualified to use the generate G-code as well with the SolidCam. So I will click here, G-code or generate, to show I could do this procedure easily for the manufacturing process. When I need to work with the manufacturing to operate the CNC machine, I could easily to apply this skill. You see in here, I got all the G-code in this file, and then I just save whatever I want for what I want for the G coding to the space. Then I can submit. Simple procedure and done for this one. Thanks for listening.